Hello, and welcome to today's webinar, Truck Weight Analysis and Weight Distribution Fundamentals. My name is Jennifer Mitchell. I'm the Senior Director of Content Development here at NTEA. Just a couple of housekeeping items before we get into today's presentation. Just want to let everyone know that recording and use of AI note-taking or transcription tools is not permitted. Any AI note takers or recording devices will be removed from this meeting. This webinar is being recorded by NTEA, and a link to that recording will be shared with you after today's event. I would also like to let everybody know that we are just about 2 weeks away from Work Truck Week. So if you've not yet registered, please do that today. And we look forward to seeing everybody here in just a couple of weeks in Indianapolis. Today's presentation will be displayed in the center of your screen, but we do encourage you to use the Zoom Q&A feature if you have questions throughout the presentation. You should see that icon at the bottom of your screen. If you do have trouble using that, please utilize the chat function with us today. All of the attendees' mics are muted, but you do have the ability to type in the chat or Q&A to reach out to us. So it is my pleasure now to introduce today's presenters. We have Circa O'Grady. She's the Chief Sales Officer at TruckScience, and joining her today will also be Jens Hellberg. He's the Chief Executive Officer at TruckScience. So without further ado, I'll hand it over to you all.
Thank you, Jennifer. Welcome, everybody. As Jennifer says, this morning's presentation is Truck Weight Analysis, Weight Distribution Fundamentals. TruckScience partnered with NTA in 2019, and we're delighted to present this webinar today. The webinar is for people with an interest in vehicle weight management who'd like to learn more about using the TruckScience Axle Weight Calculator. So weight analysis is fundamental to good truck design, as you know. And when we think of good work truck design, there are many considerations to be taken into account. So we're just going to take a quick look at some of these, and then we will get into a live demo of the TruckScience Axle Weight Calculator. We need to consider the regulations in the states or provinces in which a truck will be operated. And these regulations vary depending on the number of axles, axle spacing, tires, and more. We need to comply with OEM ratings, including gross vehicle weight rating, gross axle weight ratings, and the maximum unloaded vehicle weight, or max UVW, which is applicable only in certain cases, obviously. We need to ensure that axle weight distribution supports steering and braking ability, for example, by ensuring that a significant portion of the total weight is carried on the front axle. We usually have a goal of maximizing payload capacity. We want to right-size the truck, both to reduce capital cost and reduce fuel consumption. And we want to avoid undue maintenance or rework, or indeed invalidating the vehicle warranty. We need to be mindful of rollover stability by keeping the vehicle balanced from left to right and by keeping the center of gravity as low as possible. Turning radius also becomes important for example, a garbage truck that will need to turn in a residential area. There are lots of other considerations too, including site infrastructure, driver needs and preferences, and internal standards that are stipulated by your own organization. But in general, these are some of the things we need to bear in mind when laying out a vehicle, and we will cover them either directly or indirectly when we get into the live demo now in just a moment. The purpose of this webinar is really to be a basic introduction to the TruckScience Axle Weight Calculator and weight distribution fundamentals for people who are new to the topic or new to the tool, and then also a refresher for those who might be a little rusty. Hopefully even regular users of the tool or regular people who regularly do weight distribution calculations will pick up some tips. We'll cover how to calculate axle weights and center of gravity. We'll check compliance against OEM ratings, state regulations, and your organization's own internal best practice guidelines. I'll help you to realize your vehicle's payload potential, and I'll show you how to use the TruckScience library of product specs and how to have something added to it, I'll also explain the options for having your own products added to it. I'll show you how to share your designs with other users of the program and how to generate a sign-off document with true-to-life drawings, and that document will be customized with your own logo and indeed the logo of your customer if that's what you like. And lastly, I'll show you where to get help if you get stuck while using the tool. So we're just going to jump into the live demo now. So I'll quickly change screens here. Hopefully you can still all see that. Just let me know if there's any issues. So to start with, we're going to choose a new calculation from the top left here. Or to start a new calculation, rather, we're going to choose a new vehicle. Click on Forward here. So we can filter by makes and ranges, Super Duty, 4x4. And then we can, as you can see, there are pages and pages of vehicles that fit that filter. So we need to filter a little bit further. Go to Ford F550. We're going for a regular cab with dual rear wheels and diesel. So you can sort this table then on CA, and we'll choose this 2025 spec. Okay, so this chosen this 84-inch CA vehicle to accommodate an 11-foot service body. So just a quick tour of the interface before we carry on, so you know what you're looking at. There's a compliance dashboard here on the bottom left. We use that to verify compliance with manufacturer ratings, with regulation limits, and your own organization's internal standards, and we call those organization standards. You can also display your favorite measurements here, and I'll show you where to choose those later. So obviously, different users of the program have different interests or different things they want to highlight, and that's where you can do that. There's a detailed a weights table here with a detailed breakdown of weight distribution and color-coded compliance indicators. So right now they're all green, that's good. In this table, you will also be able to determine the maximum achievable payload when a body is added. So the payload is obviously 0 right now. There is no body for adding payload to. The menus on the left-hand side over here, you'll use those to input information about the vehicle, body, equipment, and payload. And on the right-hand side, you can switch views. So for instance, you can switch from this summary view to a bridge view, center of gravity view, and back again. And along the top, there are some, I call them completion actions. You can choose to print, save, or share your calculation. You can also choose to edit your settings up there. So that's kind of the interface in a nutshell. So now we'll start to build up our configuration here. So we'll start by adding components from these body, equipment, and payload menus on the left. When deciding whether to add an item as a body, as equipment, or as payload, we recommend the following guidelines. Bodies and equipment are permanently attached to the vehicle. Payload is loaded on and off. And a body has payload capacity, whereas equipment does not. So let's add a body from the second icon here on the left. I'm going to choose from the body categories. In this case, I'm going to choose a service body. And you can choose from preloaded standard bodies in our library. So you'll see a selection of bodies there. And again, you can filter these on keywords from the body descriptions. In this case, I'm going to add a Duramag. And I'm going to look for one with that fits an 84-inch CA. And I'll choose that first one. So now that we've got a body on the vehicle, we can see in the weights table highlighted in blue our maximum achievable payload for this setup or this layout. And the maximum achievable payload is currently 8,494 pounds. So we click on the body again as a shortcut to open that body menu. And since this is a standard drawing from Duramag, I can't edit the dimensions, but I can still override the weight and center of gravity values. It's worth noting that manufacturers who wish to add their products to our program can choose to make them available to all TruckScience users or only approved distributors. And we have recently added some new pages to our website here, which you can browse to see the bodies that are available in TruckScience. So you'll see the Duramag that I just used here. And yeah, you can browse that in your own time, but there is a new information page there on our website. So an upfitter might choose to add a standard body like we have done from the library, whereas a body manufacturer might like to use the tool to experiment with body design. And we provide templates for this. So let's just make a note of the dimensions and weight of this body, and then we can recreate it from a template body in just a moment. So you'll see the length of the body here is 137 inches, got a height of 40, and the distance from the top of the chassis to the bottom of the body, 9.6 inches. We've got the width and the depth of the compartments, and then a weight of 1,120 pounds. So I'm just going to use the scissors to remove this standard body. And I'll add a body again from the left-hand side here. Again, I want to choose a service body, but this time I'm going to choose a template. So as you can see, templates have more generic drawings, but they do offer greater flexibility in terms of what I can edit. So if I click on the body again, they come with sensible default values for dimensions and weights, but I can edit them also. So we'll just edit this one now to match the Duramag body we just had on. So I'm going to just update these dimensions as per what we just saw. This was 9.6. And we had a weight of 1,120. I think everything else is as is. And you can see that the payload is back to 8,494, which matches the payload we had when I had this standard Duramag drawing on there. You can experiment with body dimensions, weights, and center of gravity to see what it does for your payload, your overall center of gravity, etc. So that template allows you to do that. It's got ultimate flexibility in what you can change. Now is a good time to point out the color-coded indicators beneath the drawing. The compliance scorecard on the bottom left here flags any possible non-compliance with the manufacturer ratings, your regulation or bridge weights, and your own organization's internal standards. Green ticks indicate that everything is good so far. So let's open the settings dialog now to customize this dashboard. First, we'll choose the regulations that will be applied to our configurations. So I'll just pop into regulations applied here. I'm going to clear the current selection and then scroll or search for the relevant state or states. So for instance, I can look for Californian state roads, Illinois, Texas. In fact, you can choose up to 5 at once. We'll just verify our calculations against those 3 for now. We'll also look at our favorite measurements in here while I'm here. So I have added an indicator to indicate whether a CDL, commercial driver's license, is required for this setup, and we'll see that in a moment. I've also added I want to see the percentage of the gross weight that's carried on the front of the vehicle. And lastly, I want to be able to see the overall height of the center of gravity, of the overall center of gravity. So there are obviously lots more that you can choose from here, but those are the 3 I've chosen for now. I mentioned organization standards. These are the standards by which your organization wants to hold itself to account. So these are limits that are not covered by Ford in this case, and not covered by the DOT regulations in the states that we've chosen. These are checks that you put in place that your own organization would like to uphold. So for instance, I have just chosen one of these for now, and that is that the percentage of gross weight on the front of the vehicle should be at least 20%. And this is to ensure that the vehicle can be steered and stopped safely. So from now on, my calculations will be checked against that there's at least 20% of the gross weight on the front of the vehicle. These can be toggled on and off here with these check boxes. I'll leave that one on for now. So now if we pop into our regulatory compliance, you'll see the 3 states that I chose. If I look at organisation standards, you can see that there's a gross weight on the front of the vehicle is being checked. It's currently compliant. And we can see the manufacturer limits are also compliant for now. Jens, are there any questions before I go ahead and keep going?
There aren't any questions as yet. I just wanted to remind everyone, if you do have questions, just to use the Q&A feature at the bottom of the screen, and we can I can either address them there, or I can ask Circa to illustrate the answers in the live demo.
Thank you. So we've just had a look at the compliance dashboard. Now we'll move on to this weights summary table. So the weights table shows the breakdown of weights per component in the rows. So you'll see, for instance, that service body has 83 pounds on the front, is exerting a weight of 83 on the front axle, 1,037 on the rear, and that is of its total weight of 1,120 pounds. It also shows the breakdown of weights across axles in the columns. So currently the gross weight on the front axle is 5,460. The gross on the rear is 12,040, and that's a total weight of 17,500 when the payload is 8,494. So by default, the payload is being maximized as we go. And that payload figure is highlighted in blue. If we look down at the bottom 2 rows, we can see unused capacity and utilization. And these rows indicate any capacity that is being left on the table, so to speak. So when the total column, as it is now, is at 100% utilization, we know that we are realizing the total payload potential of this vehicle as is. Obviously, right now we only have a service body on there, and we may wish to add more items, so we'll get to that in a moment. But just to understand what's going on while the setup is pretty simple. The blue text in the weights table and on the drawing, the dimensions, indicates a clickable shortcut. So shortcuts open the menu on the left. For example, the body length here, and we can pop it in to see the rest of the dimensions around that. So that, for instance, we could change the body length by clicking on that body length and opening the dialog there. As you make changes to the body dimensions, you'll notice that the graphic and the weights table are updating on the fly. So I had 137 inches here with 5460 on the front. And if I change the body length to 133 inches, the gross weight on the front axle changes to 5,573. If I look at the height, I can change that to, say, 38 inches. And we can also update the material weight. So you can choose to express the body weight in absolute terms, 1,120 pounds, or you can switch that to pounds per running foot. And for instance, we can experiment with changing that from 101 pounds per foot to 91 pounds per foot. And you'll see our payload change from 8,494 to 8,605 in response to that change. Obviously, reducing the weight of the body increases the maximum achievable payload, where neither of the axles are maxed out. So let's add some equipment using the third icon here on the left-hand side. We'll add a crane firstly. So we choose that category of crane. And you can choose from a number of standard cranes in the library. So if we just scroll down here, you can see there are many brands already in the library. Or you can just search by keyword. So for instance, we could add a lift moor crane. And we get an actual drawing to match. Or if we take that one off, we can add a similar crane from Auto Crane. And you just drag it into position, you'll see the weights table is updated as we go. So next you might want to add a generator or a compressor. Again, go back to the equipment menu. Add, and this time we'll look in the other category. And again, you can filter by make here, or you can simply just search by keyword and we'll find a compressor. Again, we can position this compressor by dragging it as we did the crane, or we can open the menu to specify its position. So if we go to position here, we can move it to 4 inches from the back of the cab, or 28 inches above the chassis, around about there. If you prefer to specify its position relative to the front axle instead of the back of the cab, you can change that in your settings. Preferences, specify equipment position relative to the frontmost axle. And now if I go back to the position, I'll see that that first dimension is now relative to the front axle, 89.3 inches. You can also override its default weight and center of gravity. So just simply select the checkbox here by 432. And we'll specify that horizontal center of gravity as being 45% from the front, 45% of the distance from the front of the compressor. To see detailed position and dimension attributes for this equipment on the drawing, you can toggle this pin to pin those dimensions to the drawing. So I'll just do that quickly to show you. And you can see those extra dimensions pertaining to the compressor added to the drawing. Obviously, you don't want this level of detail on everything at once, or the drawing will become very crowded. So that's why you're able to toggle it on and off like that. At this stage, we could add a step and some outriggers among other items, but I'll skip those just to save some time here. So just to point out again that this layout is utilizing 100% of the vehicle's capacity. The gross weight in green on the total column is 17,500 pounds, and the total weight is 17,500, representing obviously 100%. The total permissible is itself, if I click on this permissible value here, it is the lesser, this total permissible of 17,500 is the lesser of the gross vehicle weight rating and the lowest of the state regulations that we have chosen. So we chose California, Texas, and Illinois. And so the lesser of those limits is 40,000 in this case. Jens, are there any questions before I proceed?
Yeah, there have been a few questions which I've answered via the chat, but maybe one of them in particular might be interesting for you to also demonstrate. The question was, whether there's an option of seeing drive or passenger side weights. And on a service truck, obviously, the crane would skew that weight to one side. So maybe you could just show the left-right distribution and maybe the top view of this vehicle. So just to demonstrate that. But other than that, please keep the questions coming.
Okay, so right away, I'll just show where you can add in an additional row at the bottom of this table, which will calculate the left to right weight distribution. So if I just go to my preferences in settings, and you see this left-right weight distribution here at the very bottom, if I add that, it will calculate the left-right distribution. I will get to the top view in just a moment to reposition these items. Yeah, I will get there in just a moment, and then it will become. We will also increase the weight of one of these, exaggerate the weight of one of the components to show you that left to right distribution. Will I carry on for now, Jens?
Yes, please do. Yeah.
Okay. Okay, so just before we get to that, the left to right distribution, we just examined this axle utilization. So I mentioned that there's 100% utilization of the GVWR, as denoted by that blue highlighting in the second last row now. And you can also see the utilization of the front and rear axles. So the front axle is at 93% and the rear is at 87.3%. If one of the axles had shown a utilization of 100% and the other had significant unused capacity, this would represent an opportunity to gain payload by moving some items towards the front or rear. But as it is, there's, the crane and compressor are not that heavy. So I'm just going to exaggerate the weight of the compressor to illustrate this point. So I just click on the compressor here. And we currently have a weight of 432, but I'm going to just model a typo here and type 4,000 pounds in there. And you'll see now that the front axle is overloaded. It's at 103% of capacity. So the permissible is 6,000, and that's the lesser of the gross axle weight rating and the regulatory limits. So we've got a permissible left and right of 3,000 and a permissible of 6,000 in total. Yeah, and you'll also notice that the payload has been zeroed because the front axle is already overweight. So if we maybe move to the top view here and take the compressor to the roadside and also towards the rear, we will see some things happening here in the weights table. So as I move the compressor towards the roadside, you'll see that we are now only overloaded on the front left corner of the vehicle. The front right corner is no longer overloaded, but the front left is. So that's moving it towards the side, towards the roadside. And then as I move it further back here, the front axle in its entirety is not overloaded, but the front left still is. And if I continue to move it further back, maybe there's a sweet spot here. Yes. So there, where I've positioned the compressor now, despite it being the weight being very much exaggerated at 4,000 pounds, we are no longer overloaded on any of the four corners. You will see the front or the rear axle is at 100% on the left right now as is. Obviously, if we moved, doesn't really make sense, but if we were to move the compressor into the middle here, we will take that weight off that left one. And now we haven't maxed out any of the four corners. I'll just move that around again. I guess this is kind of the power of performing weight analysis, is that you can calculate what is happening on each of your four corners and experiment with layout and placement of equipment to both to maximize payload and to take pressure off any particular axle or corner of your vehicle. So okay, we're obviously in the top view here. So as I mentioned, the inputs come in on the left-hand side over here, and you can choose from top and side view on the right-hand side, this orientation. Obviously, the crane needs to move over to the roadside. That will help balance things out here as well. And we can, while we're here, we can edit the compartment depth here as well. So my crane is on the curbside, my compressor is on the roadside. And before we move on, maybe now would be a good time to unoverride the weight of that compressor. And I'll also switch back to my side view. Any questions, Jens?
Yes, the questions are coming thick and fast, which is great. One question here that maybe you could quickly demonstrate is it's a question about the fuel tanks. How much fuel is in the tank, and maybe just also show how you can change the contents of the tank. Yeah, there we go. So the question was, does the data assume the weight factor of a full tank of fuel based on the fuel tank size or having dual tanks? So, yeah, in this case there's obviously a fuel tank and a def tank, and you can specify the contents of both. Yeah, so I hope that answers that question.
I can also obviously, sorry, Jens.
Sorry. There's another question there about whether we can use the software to build trailers, and the answer to that question is yes. We may or may not be demonstrating. You'll
I will
get
get to that, yeah.
Okay.
Yeah.
Okay. Excellent.
So I was just pointing out there that you can change the capacity of these fuel tanks also. So in this case, if I increase the capacity of the tank to 60 gallons, now there are 40 gallons still included in the chassis weight, and there is an extra 20 gallons which can be included in the fuel and crew, which you'll see there as the second line in the weight summary. So it does go into that level of detail. You can also change the energy source of a vehicle. And in some cases, for example, if we switch to battery electric, we should see, yes, the battery powered vehicles qualify for a 2,000 pound weight increase on the overall bridge, and that is in California and Texas. So the regulations engine is aware of those exemptions or, extra weight allowances depending on the fuel source. I'm just going to switch that back. That was diesel, wasn't it? Okay, and I will get to the trailer in a little while. Okay, so now we have a proposal to agree with our customer. The vehicle GVWR is 17,500 pounds, and the payload capacity is 7,420 right now, and that is based on this chassis with this body, this crane, and this compressor. Similarly to the body, the way I used a template body, if you don't have the drawings for the crane or the compressor, you can use template equipment items and just build up your own. I will also show you in just a moment how to import a drawing from a DXF file that you have yourself. As a body manufacturer, we might wish to send this layout to a draftsman and to get a more realistic body drawing. for our customer sign-off document, which I'll get to later. So in this case, we would just save this calculation. So I'm going to just save as, and I'll save it in my personal folder. Saving it in my personal folder makes it available to just myself in future. If I were to save it in my team folder, you can organize your team folder however you like, but your colleagues that are also using the tool then can collaborate on your layouts with you. I'll just save this one in my team folder for now, and I'm going to share it. So I've got another little icon here to share. And for instance, I'm going to share with the fictitious draftsman at my company and make some comments and invite them to provide me with the drawing for the body. So when that drawing comes back after some time has elapsed and we receive a drawing back from our draftsman, we can replace this template body with an actual body drawing. So I'm just going to take this body off, click on the body, and oops, just struggling a little bit with zoom controls and on top of my program here. I'm just going to cut the body off and then choose body, add a service body again. And I'll import a DXF. So I'm just going to choose a file for my desktop. And I'll give it that length of 133 that we had. Or I'm going to give it that dimension from the top of the chassis to the bottom of the body again. And just pop into the width here, override the width, 94. And we had those compartments at 25 inches each. And the body weight, I'm going to give it a weight of 997. It should really match whatever you used earlier. And then we'll just save it as my service body. So that is just the process of adding a body from a DXF drawing. If I click on this body, I can also choose to save this body in my team library to make it available to my colleagues that are also using the program, so we all do not have to repeat the work of importing that DXF drawing. I can additionally choose to share it to my approved distributors. And I can allow them to see a read-only copy or an editable copy. And lastly, the most public option, I suppose, is to share it to the public library, and then it will be reusable by all users of the TruckScience tool. And obviously some manufacturers, as you'd have seen in the library there, see that as a way to promote their products to upfitters or distributors that are using TruckScience. Let's cancel out of that. And I'm just going to reposition these items to meet my body. Any questions before we move on, Jens?
Not just at the minute. I think I've answered most of them. I'll get back to you if that changes.
Okay.
Thanks.
So up to now, we've been using what we call the default maximized or simple payload. It's an evenly distributed load with the optimum maximum payload for this particular configuration at 7,432 pounds. If I click on the payload icon here on the left-hand side, I can choose to add some user-defined point loads by switching from simple payload to detailed payload. I'm just going to add a generic payload template item, which right now is just a rectangular or piece of equipment. Again, you can import drawings for your payload items if you want to make them more true to life. But if I hover to highlight this and click to edit it, it opens my menu on the left-hand side, so I can give it maybe a more recognizable name that will appear in my weights table. So in this case, tools. And then I just want to specify dimensions and weight for this too. So I'm just going to change the dimensions. Simply give a length, height, and width to this. Specify its weight. In this case, 750 pounds. And I'm going to position it a little bit in from the edges. So I'll just 2 inches from the headboard, from the floor, from the sidewall. And now we have some tools on there. Let's see what happens if I accidentally make that weight 7,000. And as expected, the front axle is now overloaded, highlighted in red. We can see that it's the manufacturer limit that has been exceeded here and not the regulations for Texas, California, and Illinois. And that's just highlighted in our compliance dashboard. Manufacturer limits have been exceeded. We can see that we have a gross weight on the front of 7,494, even though the maximum permissible on the front axle is 6,000. So we're overloaded on the front, and we're also overloaded there on the left front corner. If I pop back to the top view and move these tools to the right, we will become overloaded on the right corner instead. And as I move around, as I go, you can see that we're overloading one corner or another. So just to show you where those limits are coming from, if I click on the permissible value here in the table, 6,000 pounds, we've got a gross axle weight rating of 6,000 and a bridge or regulation limit of 20,000. So the lesser of the two is the 6,000 permissible on the front axle. Of course, upgrading an axle can sometimes make this problem go away. So I can override that gross axle weight rating to 8,000. And now we're no longer exceeding the 6,000 front limit, but we still have the issue with our left to right distribution. And if I go to my top view and move those tools into the center, that problem is now also solved. Of course, I can also just override the weight of the tools back down to the original, which was 750 pounds. So you'll just remember that those blue values are shortcuts. So again, I can click on that payload link on the drawing to change the weight of that payload item back to 750. Can of course copy a few more of those payload items on there, and they will be just placed along the load deck. Just cut them back off again. Okay, so Jens, are there any more questions before I add the trailer?
I suppose there's a question around whether there are any training videos or articles where one can learn, kind of do some self-learning on the application. Maybe you could point that out. There's also a question on who the target audience is of this product. yeah, maybe you could live answer those two.
Okay.
There have also been some questions around pricing, but maybe, which I've partially answered, but maybe you can also just point people to where they can find more information on that.
Okay. Yeah, firstly, we're asking about training materials or videos. So if you go to truckscience.com, our website, and you'll see here underneath resources, there are both explainer videos and recorded webinars. So we normally run a webinar every couple of months or so, and all of the webinar recordings are available underneath the webinars link there. These explainer videos are much shorter. They tend to be 2, 3, 4 minutes long, and they will deal with one topic at a time. So understanding the weights table, calculating center of gravity, how to import a drawing, how to add axles, edit axle ratings, etc. So if there's anything that you would like another explainer video on, please let us know and we can add them there. But those are very short snippets of training material. So that was the videos. Somebody asked about the target audience. So this, as I say, a picture paints 1,000 words. The tool is generally used by chassis dealers, body manufacturers, upfitters, fleet engineers, and fleet acquisition specialists in cities, fleet managers. It's also used by accident reconstruction, and I guess we're just coming across new uses all of the time. I think there are over 300 NTA members using the tool now, so there's a lot of synergy there with the NTA members, and for that reason, we really value our partnership with NTA. Somebody else asked about pricing. So again, the pricing is on our website. If you just go to this pricing page, you can choose between monthly and annual billing to see monthly and annual pricing. Everything I'm showing you here is included in the professional edition, and that is billed annually at $1,800, and you get 2 extra users for free with that. So you'll actually have 3 users for $1,800. I spoke about making manufacturer product specs available to only approved distributors. If that is the case and you need that functionality, that is available in the Enterprise Edition. So if you're a manufacturer and you want to share your specs with an approved list of distributors, you can go for the Enterprise Edition. And because there are lots of optional features, I guess, including system integration in that one, we will quote you separately for that. But please reach out if you would like a quote for the Enterprise Edition. Anything else, Jens, before I go on with the trailer?
No, I think that's it for now.
Okay. All right, so let's add a trailer. First, we'll obviously need to add a hitch. And again, I just find that under the equipment categories. And I'll just find one that I am familiar with here. So we're just going to find that conventional hitch, and then I will grab a trailer from the trailer menus on the left-hand side. So you'll see as I said, all of the inputs really go in on the left. We've got chassis, vehicle chassis, body, equipment, payload, and then this first one is trailer one. So I'm going to choose a center axle drawbar trailer. And I'm just going to choose the center axle drawbar plus beaver tail that I've already added to my team library. And there we go. So, and I'm going to put some payload on there also. So when you've added the trailer, you get the same kind of menus you already had above. So you've got trailer body, trailer equipment, and trailer payload. I'm going to switch that payload to detailed again because I don't want just the evenly distributed load. I want to add a bobcat. And now that I've added payload, you'll see that the tongue weight or hitch load is expressed as a percentage of the total trailer weight. So in this case, 6.6% of the total trailer weight is being transferred onto the hitch. And by total trailer weight, I obviously mean the trailer and its payload. So 6.6% is being transferred forward there. So if I drag the bobcat forward or backwards, I will increase or decrease that tongue weight. So I'm just going to drag it back a little bit. You can see the weights table is recalculating as we go. And now we've just got 1.7% of the total trailer weight being transferred. You can switch to the top view again to center the payload laterally. And back again to the side view. You can obviously explore these views in detail in your own time, but I can give you a quick rundown through them, I guess, now. So we've got that overview at the top, summary, and then the overview of the vehicle will give you a detailed breakdown of the vehicle's unladen weight. So you'll notice that some of the components are exerting negative weight on the front axle. So in this case, the crane and the hitch are exerting negative weight on the front axle because obviously their weight is mostly distributed towards the rear. But if I go back to my summary, I can see that the front axle is carrying the front axle of the vehicle is carrying 47% of the gross weight, so that's not a problem. There's also a bridge view, and the bridge view compares the actual weight on each axle group with the permissible weights as per the bridge law. So those of you who are have a good understanding of the bridge law would be able to see what's going on there. There's a center of gravity view, and the summary. In the summary, you can review center of gravity points, including the overall vertical center of gravity of both the vehicle and the trailer. So the vehicle's overall center of gravity, if you look towards the front here, is about 36 inches from the ground. You can pin any particular, the center of gravity of any particular item to the drawing. By default, they're not all shown because, again, the drawing will get quite busy, I guess, if you pin them all on there, but of course you can, if that is something you want to be able to see all of the center of gravity points, just toggle them on and off like that. There is a, sorry, Jens.
Oh, sorry. There's a question here about the tongue weight there, whether the software is going to highlight any issues there. And my answer there was that I'm not sure whether there are any regulatory kind of guidelines there, but maybe you could just show the organization standard where you can specify a range for the tongue weight as a percentage of the trailer.
So I'll just choose it here, tongue weight as a percentage of trailer weight. I'll toggle that organization standard on, and then I can set a tolerance, I guess. So for instance, if it needs to be between 10 and 40%, this comes with a warning that I'm not sure what these should be, so I'm just going to guess. And now you'll see that my organization standard is broken there. The tongue weight is not complying, I suppose, with the range that I specified. And in that case, you may also want to include tongue weight as a favorite measurement. I'll turn them both on there. And now you can see that the actual tongue weight is minus 8 pounds or minus 0.1%. So if I move the bobcat forward, I just want to exceed 10% here to get my, yeah. Okay, so I'm not sure if you're happy with the bobcat in that position, but it is, it has fixed the problem where the tongue weight was not within my own organization standards.
There's another question there. Are we able to import existing load expert files? So the answer to that question is unfortunately not. Um, but but it is possible to obviously recreate that calculation within our platform from a printout from Load Expert, and our support team would be more than happy to help you with that.
Is that it?
Yes.
Okay. So I was just going to show you the turning radius, and that's another alternative view here on the fourth one down on the right-hand side, and this represents the smallest circle in which the truck can turn. And then we already looked at the side and top view, etc. So I'll just pop down here to notes and warnings, and you can review some notes here about the regulations that have been applied here, and then in general, just we can also see the vehicle's static rollover angle and the static rollover threshold, assuming a stiff suspension and no tire flex. Anyway, I won't read through all of those notes, but you will see warnings in there as well if there's anything to be concerned about. Then lastly, to export the current view to a PDF document customized with your logo, you can click this PDF icon. In fact, it's not just the current view. You can choose as many views as you want to include in this in your settings. So you'll obviously have uploaded your own logo here. You can add, for instance, a customer logo. To this PDF, something like that. You can add a signature. You can add some additional information also by adding a call out like this. More notes. Okay, so that is the PDF, and again, you can include as many or as few views as you like. The right information in the wrong hands, I guess, is not the right information. So you may not want to include all of the views for all of your audiences, but you can do so if you like. And then, of course, you can print, download, or email that PDF as you please. Lastly, there's a live chat here in the bottom right-hand corner. If you do need help while using the tool, you are welcome to pop open that chat. We can organize then to share screens and assist you with anything you might be struggling with. So I will just save my calculation now that I'm done, and I'm just going to head back out to my presentation, but I'm pretty much done there too. I know we are tight for time. Oh yes, I'd already shared this calculation with my draftsman, so at this point I would be invited to, tell them about anything I have changed in that, and we leave it at that. Okay, so if I just quickly jump back to my presentation, I realize this has been a very quick tour. If you would like to schedule a demo where we work through a calculation that's relevant to your own organization, please feel free to use your camera now on your phone to open that URL and choose a time that suits you, and I will be happy to work through a calculation that's maybe more relevant to what you do. You'll find us on TruckScience.com, as I already showed. We at NTA also have a page on NTA's website about TruckScience. We are looking forward to joining NTA on their booth at Work Truck Week in a couple of weeks' time, not even. And if you'd like to see any other events that we will be attending, they are on our website, truckscience.com/events. Please feel free to take a free trial from our homepage, truckscience.com. Just start free trial. I think if a name and an email address, and you'll be right in there. And you can pop open the chat, of course, then if you need any help while doing that. We've already covered pricing, and that's all from me. Any final questions before we wrap up?
No, it looks like all the questions have been answered. Nothing nothing unanswered.
Great. Well, thank you, Circa and Jens, for the informative webinar today. Really appreciate it. Just a reminder to everybody, we will send a recording out to you all following today's webinar. But like Circa mentioned, there are plenty of ways to get in touch with Truck Science, as well as feel free to reach out to us here at NTA if you have any questions, and hope to see a lot of you in person here in just a couple of weeks. Bye, everybody.
Thank you, Jennifer. Bye, everybody.
Thank you. Bye.